This video is all on trigonometric models. We are going to be graphing sine graphs and cosine graphs. So the first thing we're going to do is talk about the unit circle. The unit circle is a circle that is centered at the origin, so that means the point 0, 0, and it has a radius equal to 1. So right now I'm going to go ahead and draw a circle. I'm going to place it on a coordinate plane. And what I'm going to do is identify these 4 points that are on the circle right here. So we're going to start by going around the circle in degrees. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. The other thing is, since we know that the radius is equal to 1, that means that I can figure out the ordered pair at each one of these points. Because this radius right here is equal to 1, I know that the ordered pair at 0 is 1, 0. The ordered pair at 90 is 0, 1. The ordered pair at 180 is -1, 0. Down at 270 is 0, -1. And of course, back at 360, we're back at 1, 0. Because of the fact that we have a unit circle, I can basically go ahead and create any triangle that I want inside of my unit circle. Right here, I'm going to call this central angle theta. And I know that my hypotenuse is equal to 1. So I'm going to call this x because it's on the x-axis. And I'm going to call this length right here y. Now, if I have to find the sine of theta, remember that the sine of theta, if you remember from SOHCAHTOA, in a right triangle, the sine of an angle is equal to its opposite side over the hypotenuse. So the sine of theta here is opposite, which is going to be y, over the hypotenuse, which is 1. So I know that the sine of theta is simply just the y coordinate. The cosine of theta, if you remember from SOHCAHTOA, is ka. It's adjacent over hypotenuse. So according to theta, the adjacent side is going to be x. Because this is a unit circle, we know the radius is 1, so the hypotenuse is 1. This means that the cosine of theta is equal to x. So in terms of sine and cosine, in an ordered pair, x, y, I know that this is the same as the cosine of theta, sine of theta, in a unit circle. We're going to go ahead and use this information to help us graph the sine and cosine graphs. Before we graph the sine graph and the cosine graph, I'm going to make a table of values, and I'm going to write theta, which is going to be my angle. Then I'm going to write the cosine of theta, the sine of theta. So if theta, which is my central angle, is 0, 90, 180, 270, 360, I'm basically going around the circle one time. Then I want to figure out what would be cosine and what would be sine. So the cosine of theta at 0 degrees right here is the x coordinate, which is 1. The cosine at 90 degrees is the x coordinate 0. The cosine of 180 degrees is going to be -1. The cosine at 270 degrees is going to be 0. And then if I'm back at 360, then cosine is going to be 1. In terms of sine, the sine of theta is going to be the y coordinate. So at 0, the sine of 0 is 0. Then we go 1, 0, -1, 0. And all I'm doing is once again using the ordered pairs at each one of these points and identifying the y coordinate for sine and the x coordinate for cosine. So we started with the unit circle. And looking at the unit circle, we identified that cosine of theta is the x coordinate, sine of theta is the y coordinate. We went ahead and we set up a table of values, and now we're going to use that table of values so that we can graph these and you can take a look to see how they look. So I'm going to split this up into 90, 180, 270, 360. And then I'm going to go to positive 1 and down to negative 1. So let's see what happens when I graph the cosine of theta. So I'm going to look at these values right here as ordered pairs. That means that at 0, I'm at 1. So 0, I'm at 1. At 90, I'm at 0. At 180, I'm at negative 1. 270, I'm at 0. 360, I'm back to 1. So this is what my graph looks like. And I have just graphed y is equal to the cosine of theta. So this is what the cosine of theta graph is going to look like. Notice that all of these graphs are going to have what's called a principal axis. So some people call this the midline, but it also is referred to as the principal axis. So notice that basically what is happening, the behavior of the graph, I started at 1, I went to the principal axis, I went down to negative 1, I went back and then up again. So this pattern would just basically continue over and over again. Up, back, down, back, up. And then if I kept on going, it'll be back, down, back, up, back. Okay? So that's basically what is happening here. Take a look at the shape of this graph. Now that we've seen what the cosine graph looks like, we're going to go ahead this time around and we are going to graph the sine graph. Okay? So that means that at 0, I'm at 0. At 90, I'm at 1. At 180, I'm at 0. At 270, I'm at negative 1. And at 360, I'm back to 0. Go ahead and connect these with a nice smooth curve. And this is what y is equal to the sine of theta is going to look like. Notice once again that we still have this main principal axis or midline that's basically cutting this in half. Our graph is starting at 0. It goes up, back, down, and back. So it's constantly oscillating back and forth. The behavior is that it goes up, back, down, and then back, and that would basically continue.